Hey everybody, Oster's here. We're going to take a look at the second problem of the four we have this week in week 21, orbital motion of a satellite. In this motion, or in this program, you are determining the orbital speed and the period of a satellite placed into known orbit around a planet. So we hit begin, and the first thing they know is your satellite's now on the surface. Determine the speed and period of the satellite when placed in orbit. So if we show the question, we have a few things to write down right out of the gate. We know, let's see here, that the mass of the satellite, little m, is 506 kilograms. We know the mass of the planet, which we'll call big M, or m sub p, is going to be, let's see here, 2.2 times the mass of Io. So that's going to be 2.2 times the mass of Io, which mass of Io is 8.93 times 10 to the 22nd. So we're going to go with, let's see, 8.93 times 10 to the 22nd kilograms. So that means mass of the planet is going to be, let's go ahead and plug this in, 2 times 3, 22. Get 1.9646 times 10 to the 23rd kilograms. All right. We also know the radius of the planet. We'll call that R, big R of the planet. 2.3 times the radius of Triton. Radius of Triton, let's see, radius of Triton is all the way down here at the bottom. 13526 and 2 zeros. 13526 and 2 zeros. 13526 and 2 zeros. And that's going to be in meters. So we can calculate RP. It's going to be 2.3 times 1352600. And I get the radius of the planet to be 3110980 meters. All right. And height, altitude, is 1611 kilometers, which I'm just going to add 3 zeros to convert that to meters, which means the radius of orbit, I'll call it R of the orbit, is going to be the sum of the radius of the planet, 3110980, plus the height above the planet, and that's going to be 4721980. All right. So they want to know the speed of the satellite in meters per second at that radius and the period. All right, so let's see if we can't figure out a way to do this. We hit hide question. Let's see here. Determine the speed and period. Okay, so I know that this must be true. And I also know that the velocity is gm over r square rooted. So I'm going to go ahead and calculate the velocity. It's 6.67 times 10 to the minus 11 times m, which is the mass of the planet, 1.9646 times 10 to the 23rd kilograms. Divide all that by the radius of the orbit, which is 47,219.80. And I'm going to take the square root of all of that. And I get V to be 711 times 1.9646 E23. Divide that by that number. Take the square root. All right, so I get the velocity to be 1,665.85 or 86 meters per second at that radius. All right, And let's see here. If that's the velocity, that's my first answer. And what else do they want? Let's just double check. They want the velocity in meters per second, the period in hours. Okay, so we hit hide answers. And they want the period now. So the period is going to be, let's see here, it'd be 2 pi r divided by that velocity, according to this equation up here, right? So 2 pi times the radius, which is 4721980. Divide that by the velocity, 1665.86. And I get the period to be 17,810.1 seconds, which if we're converting to hours, you divide by 3,600, and you're going to get 4.95 hours. So this thing orbits every 4.95 hours. And now I am ready to go ahead and enter my answers. My speed is 1665.86. My period in hours is 4.95. Making sure we enter it in hours and not in seconds. We hit submit, and we're going to launch and see if we are correct. Testing our answers. So we should see this number go to about 4.95 once it reaches all the way around back to that point. So it's going to test one revolution and make sure that it is in fact correct. And it looks like we're about halfway through in about 2.45 or so. So I think we got this right, but let's just double make sure. Numbers look good so far. Calculations are correct. Excellent. Satellite launch cost you $75 million. I hope you didn't mess up on your calculations or you'll be looking for a new job. That's absolutely correct. But thankfully we got it right, so we're in good shape. If you have questions, feel free to pop in for office hours, or of course, take a look back at the notes on uniform circular motion. That will definitely help you here.